Hello everyone, and welcome to this next video discussion in the RICS Tech Partner Program. My name's Andrew Knight and I work within the Standards, Regulation and Thought Leadership part of RICS, the World Built Environment body. We have over 130,000 members worldwide, working right across the property life cycle, working within residential, commercial property, infrastructure, land. So a very broad profession with a very broad set of practice areas, and clearly the impact of data and technology is incredibly powerful and important on such a wide-ranging sector. And today I'm really pleased to have René join me from Alice Technology. So René, please do join me.
Hey Andrew.
Great to have you on the call today, spanning the Atlantic Ocean with myself in London and you in Los Angeles. So what would be great to do first initially, I think, would be to have a bit of a question around your kind of backstory, because although the bits and bytes are always fascinating, it's really interesting to hear how you've arrived here in terms of your backstory and ending up in this kind of sector and, you know, designing these kind of solutions.
Yeah, I guess the backstory is my dad was a civil engineer.
Yeah.
And so when I graduated high school, he gave me a pretty good piece of advice. He said, you know, son, study anything you want, just don't study civil engineering. Like, okay, I was a little bit lost at what I want to do with my life, but it has become blazingly clear to me now. But yeah, I like to build stuff. I thought it would be a cool job, right? I thought it offered like international opportunities, right? Like I thought law is a lot harder to move around, right? And so, you know, people need to build things everywhere. I thought you know, there's some pretty exotic destinations you can end up in, and I have, right? And the concept of like putting big things into place that are going to be there for a long time just really excited me and continues to excite me. And so, yeah, that was kind of how I got into it. I like to build stuff. I built underwater pipelines, did a $350 million gas refinery next to Abu Dhabi, the cruise ship terminal in Amsterdam, the Bentley Motor showroom in Dubai, a whole bunch of projects around the world. I was in Afghanistan, believe it or not, for a year.
Yeah.
I was a civilian contractor. So I worked for a German company. Our slogan was Haro Construction Afghanistan. Take it easy, we'll build it again. And so, yeah, I mean, did that, ended up doing my PhD at Stanford. Did this thing you call it an industrial PhD, 6 month on, 6 month off.
Yeah.
You know, go to school, tinker around in the lab, you know, create some algorithms, go back into the field, try them, right? I kind of bounce back and forth. And so currently I'm an adjunct professor at Stanford. I sort of help co-teach the construction management class down there. And yeah, I've developed this, or we've developed this generative construction simulator, is what we've got. It's called Alice. So that's kind of the backstory, I guess.
So what made you go into that kind of, because obviously it's had a huge effect in terms of what you're doing now, but what made you come out of industry, as you say, in that kind of 6 months off, 6 months into academia? What drove that kind of direction into academia?
You know, it's a great question, because a lot of people, when I told them like I want to do a PhD in construction, they're just like, what? Like, why on earth? That doesn't make any sense. Like, PhDs make sense only for like biotech, and you'll earn less money, like you'll be less employable, right? It's the dumbest thing I've ever heard, and you know. But like the truth is, a lot of decisions I made in my life were, quote, the dumbest thing people have heard, right? Like going to Afghanistan, you know. Truthfully, like on the, you know, list of stupid ideas, like it's got a placing, you know. So for me, you know, I think that there's a couple of things that, you know, ideas that I had. One, I like theory, right, which is kind of maybe, you know, interesting, right? But like I enjoyed physics, right? I sort of fantasize my idols were, you know, like Schrodinger and Einstein and Heisenberg and all that kind of stuff, right? And so I thought, like, you know, I was like, wow, it would be pretty cool to invent a theory, right? And you know, doing that in physics is, you know, I assure you, a hell of a lot harder than doing it in construction. But 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 I think that was part of it, right? I think that the other part was my dad had a PhD,
Mm.
and it's interesting because he got one, but he did some work in academia, but he moved on, right? And so I was like, well, was it a waste of time? And he said, it taught me how to think. It taught me like how to be discipline my thinking, discipline
Mm.
my analysis, this mental sort of intellectual rigor, right? And so I thought to myself, like, yeah, that sounds like something that I'd want to do. I'd want to spend some time thinking about, a problem. And so for me, I always joke, like, if anything's going to make you stupid, it's 5 years of school, right? So I went to my, advisor at the time and I said, hey, I want to do this thing where I work for 6 months a year. And, again, like most people, like, that's the dumbest thing I heard, right? It's going to take you forever. Like, you'll never finish. And so, but like, it took 6 years,
Mm.
which is the average duration, right? Um, but, I thought to myself, like, hey, I really want to work, if I'm going to write this PhD, I want to work on something that's useful.
Mm.
Like, I didn't think like, hey, I'm going to go invent this Alice thing and solve, construction, generative simulation, that kind of stuff. But I was like, look, if at least I want to solve a problem. So whoever comes after me can pick that up and use that to go, not that engineering mindset of solving problems, which really I think fundamentally is what engineering is about, right? We solve problems, right? And so that's sort of how I ended up doing it.
So what do you think that, given that powerful combination of that kind of not only a real practice background in civil engineering, but also then that almost that dual track of doing the PhD at the same time as actually working. How has that kind of changed the way you look at it? Because I mean, you joked about your interest in quantum mechanics. I mean, presumably you're not applying the kind of uncertainty principle to building pipelines, but it's an interesting kind of theoretical physics approach almost to looking at problems and doing thought experiments maybe. And how has it changed the way you've looked at your work, given that you've now blended it so strongly with that kind of more academic theoretical approach?
So there's like, I mean, first of all, I'm half Czech, half Lebanese, right? And so very early on, I realized that, hey, stuff that's not valuable in one location is valuable in another, right? And so very quickly, I started to realize that, like, the best engineers are also artists, and the best artists are also mathematicians, right? Like, so, the way that modern schooling works is like people try to pigeonhole you, box you into like,
Mm.
okay, that's what you do, right? And which like, don't listen to other people, right? And so to answer the question, what I really learned was that this experience in Afghanistan, in which everybody was like, oh, it's the dumbest thing I've heard. But think about it, right? I was 22, right? And they're like, the British, forces gave me 6 pages, literally six, A4 sheets of paper with some drawings on it. And I got 60 guys, and they're like, go build a military base. And so, sitting there, like, what was kind of cool about it was that I wasn't tainted with the way things were done.
Mm.
I was like, oh, I like, how would I go about building it? How do I go about designing it? Oh, well, wait a minute. If I design the structure, that affects the architecture. If I design the piping, that affects where what columns will go. And if I don't order the materials in time, then it's going to be late. Like, all those sort of interconnections, right, were really live. And the only way you could do that is when you have 100% profit margin because of the risk.
Mm.
Right? You can't have a 22-year-old kid, responsible for that kind of, capital project, right? But to answer the question is like, so that experience, when I started the PhD, it was again like the fact that I was bouncing between, and in hindsight, like, I think that's like, I don't know if it's the only way that I think you should do a PhD, but I'm really just blown away that that's not a regular option. Because what was really interesting was that it wasn't just useful for me, but it was useful for the companies that I was
Mm.
interacting with during the 6 months I was working. Because I was working for this company in the Netherlands, and I really think that after 3 years of sort of bouncing between them and the university, right, that they became one of the most technologically advanced construction companies in the Netherlands at the time. You know,
So, as you say, that sense that it's a one-way street when actually it's a two-way street perhaps isn't isn't understood, and it's almost like a, I don't know whether you have the same phrase in the US, but that kind of almost apprentice model where you have people who are deliberately spending half their time working, half their time on an academic program, and that perhaps we don't do that enough, that there's this sort of sense of a much more binary, you do academia, then you do industry, and then you might return, but there's no kind of hybrid.
Yeah. And it's really, I think, a mistake. And it's a mistake. Like, it's also, oh, you are a scheduler. That's it. So that's all you do. You do scheduling. You're an estimator. That's all you do. You do estimating. It's like, not really. You know, talk to a scheduler. They probably know a whole bunch of stuff about estimating, right? Talk to, you know, like, and what's interesting is this, at our company, we tend to sort of view people more as generalists, right? Like, you know, it's okay when someone says, hey, I think you're screwing your job up, which is interesting. We brought an advisor in, and literally the first thing that hit him was he called me later that day and he said, I've never seen a group of people that are that comfortable with someone else telling them how to do their job, right? But that, you know, like, don't box, like, don't let the world box you in, I guess, is the point that I've learned.
So Rennie, tell us, what is ALICE? How can you summarize that for us? Obviously, there's been a long, fascinating backstory to get you to start building ALICE, but tell us what ALICE is and what it's trying to do.
I mean, ALICE is an acronym. It stands for Artificial Intelligent Construction Engineering, right? We thought it sounded better than ACE, so we also, when you spend, you know, 10,000 hours in the lab alone with something, you guys get to talk, you know. So Alice was my friend for a long time, and she still is. But uh, Alice was basically my perhaps naive, you know, answer to the problems that I saw in Afghanistan, right? You know, I mean, I was building landing strips for F-16s, and it was like, okay, what's the fastest way to sequence the work? And like, I remember thinking, like, man, I got to be stupid. Like, I can't figure this out. Like, you know, do I put 10 people over here, 5 people over there? And, you know, like, how do I sequence the work? And so, I guess in a nutshell, Alice was always supposed, like, my vision was really simple, which was, I want to come to the construction site in the morning. I want to pour myself a cup of coffee. I want to go to the computer and I want to say, here's what happened yesterday. And it says, all right, go walk the site. And it starts crunching all of these variables for me. And I come back and it says, okay, well, you guys are late. And here's 3 options you have for mitigating that delay. You can do overtime, here's what will happen, and so on and so forth. So that, I guess, fundamentally, the idea was always simple, right? Taking it from idea to actual reality is the, you know, the Thomas Edison quote, which is, what innovation is 99% perspiration and 1% inspiration, you know. But, you know, it took many, many hours, right? It was like many, many years, at this point, 13 years for me. But Alice is generative construction simulator. What that means is that the way I explain generative construction is through an example of parametric design. And so parametric design is a relatively simple concept. If you are unfamiliar with it, you will be an expert in about 30 seconds. And let's assume you want to draw a cylinder. So you know, draw 2 circles in a plane. Someone comes along and says, hey, I want a bigger cylinder. You redraw it. Smaller, so you got to redraw the cylinder every time there's a change. Unsurprisingly, you know, I like to joke that as humans, one of our finest qualities is that we can be lazy. So someone, you know, someone somewhere along the line said, hold on a second, why do I have to redraw this thing every time? Why don't I just have parameters, a height and diameter? You change the parameters, the tool redraws the object. We tend to call that BIM. Building information modeling is fundamentally 2 technologies, parametric and it's object-oriented. So my boss in Afghanistan walked in the office and he says, hey, I want to move the staircase to the other side of the building. So I'm thinking, drat, like, that's 46 drawings. Like, I've got to literally ripple that change, like the 3D version, the cross sections, the elevations, you know, like, what a pain in the rear, right? So we redid it, or I redid it. If you have a BIM tool, you simply move the staircase and everything updates. So that's been done in design for, you know, 30 years. It started with a company called PTC, and they did it for mechanical engineering. The reason it's taken so long to get to architecture, our field, is not because, you know, we are lazy and stupid and we don't want to innovate and all this kind of stuff. It's actually because the machines didn't catch up. Turns out models for buildings are bigger and more complex than models for engines. And so PTC has been trying to do it since the 80s or 90s, I should say, right? It's just that the processors just weren't simply fast enough to crunch those kind of variables. And so what we have done with Alice is we have basically brought that kind of technology to construction. And the parameterization lies in the ability, and I think this is kind of the holy grail of construction, right? Is you can add a crane, resimulate, add a crew, try delay. Check this out. You can change the design, upload the new design, copy the rules from the old design, hit resimulate. For the first time ever, you can build something 10, 20, 30 different ways before you build it. So that's,
as you say, it needed that combination of, I suppose, raw computing power to some extent, and the development of some of the algorithms to actually allow that to happen, because the complexity was just beyond the technology, presumably.
That's exactly what's happened, right? 2017, I think, was the sort of the turning point for construction, and I think that happened for several reasons. One, the turning point being $1 billion of venture capital was poured into construction. Right, that is a lot of money, right? You know, you can build a company you can build a prototype for $1 million, $2 million. You can build a company or something that's kind of, you know, sellable-ish for 5-6 million. $1 billion, right? You know, that's a lot of those companies that have been basically given the, you know, the ability to sort of, you know, innovate. That's happened because the processors caught up, right? B, design has now been digitized. The input to construction has been digitized. Cloud computing, again, has unlocked even more processing power, right? And so like basically in my mind, the machines have finally caught up. It's really exciting to see what's happening, right? Because there's companies like our company and others that are really riding that wave.
So what do you see the future looking like? I mean, as you say, to some extent, the technology is already caught up and it's allowed you to develop Alice. Where else do you think AI can start being applied to what, as you said, is a very complex subject, particularly when it's civil engineer, let alone buildings, but, you know, civil engineering with that level of complexity?
So yeah, so what's happening is the construction industry is, you know, getting digitized. You know, forgive me for using a buzzword, I tend to avoid them, but slowly what's happening in construction today is what happened to manufacturing in the, call it, 70s, 80s. Right. If you thought of manufacturing, right, and go back to these are stories I've heard from my grandmother, right? You know, my grandfather working in factories, right? Factories were considered, you know, similarly to what construction sites are today. Dirty, not high tech, you know, not a fancy job, you know, long, dreary hours in the factory, polluted, you know, unhealthy, no light, so on and so forth, right? Today, when you think of factories, right, that's not usually what people think, right? If you think of you know, car production facilities, et cetera, right, you're thinking high tech robots, you know, they're generally clean, so on and so forth, right? And I think that's what's happening in construction today. And so to answer your question, different parts of the construction, call it ecosystem, are getting put in the computer, right? What we have figured out is how to simulate. We have a machine or a lab that basically allows you to build a project 20, 30 times before you build it. Kind of useful. You can figure out, you know, what the impact of fast drying concrete will be. You can figure out how to resequence around a delay instantaneously. You can figure out how, you know, what should I build it with 2 cranes or 3 cranes or 4, or, you know, like all these questions you can answer. But, you know, you know, if you look at acquisitions by Autodesk, right? You look at PlanGrid, you know, 800 something, $900 million acquisition, right? They digitized something really simple, right? Drawings on a construction project, right? You look at Building Connected, so they're digitizing the supply chain. What's really interesting there is that subcontractors are suddenly an entity in the system, right? And so what I'm trying to explain is that each of these companies is digitizing a different piece of the puzzle.
Mm.
And what's going to happen is that those pieces are going to get integrated into some kind of a, maybe orchestrated is too strong a word, right? Because we don't have the data schemas and the standardization in our field, right? But the integration is happening. And what is going to happen to our field is that there's a new ecosystem, right, that is getting defined in construction. And that new ecosystem is based on a new currency, which is data.
Mm.
You know,
As you say.
and it's not a one person or one company game. In my mind, there's going to be a group of, call it 30 to 50 companies that are going to take a substantially higher portion of the new value that's created than other folks.
Mm.
Right. And what's really interesting about the way this is getting played out is that every person in construction today can be part of that innovation or that wave, right? It's kind of similar to when I was talking earlier, which is like, don't box people in or don't think
Yeah.
about it in boxes. What you start to realize, like when we started this, and this is, back in 2014, 15, I was like, oh, we're doing the cool stuff. We're working on the high tech stuff. In the last 3 years, I've realized, if you're someone at a construction company, you suddenly have access to 200 R&D departments, right? The speed at which you can, evaluate, or identify, evaluate, and integrate those quote R&D departments, those technologies, those startups, right, is basically the name of the game. And so it's really, really fascinating, right? Every single person, no matter where you are, whether you're working in a startup, whether you're working in academia, whether you're doing podcasts, whether you're working in government, standardization, codes, like all of that is rapidly changing, right? And I think that's great. I think it's really cool.
So I guess a final question, thinking in terms of how far you've brought Alice, what are the best kind of fits in terms of the projects and kind of companies that can actually take advantage of it? Because obviously there's such a broad spectrum of stuff going on in infrastructure. What's the best fit at the moment? Where are you seeing the real kind of power of it?
Yeah, so Alice tends to reduce construction durations by about 17%, labor and equipment costs by about 13%. That's what technology does. That's not surprising. And what we've seen at Stanford over and over again is if you can generate lots of solutions in a computer, compare them to human-made solutions, you see about a 20% improvement. Rough order of magnitude, depending on the problem. So the types of projects that Alice works on. What's interesting is the technology works on just about any kind of project you can think of. We've run it on parking lots, high rises, data centers, hospitals, bridges, tunnels, residential, like you name it. We focus on projects that are $100 million and up. That is where our focus is. We are releasing a set of features, for example, the 2D version of software that doesn't need a 3D model to be run, but we'll start basically moving towards that mid-tier, mid-level market.
Yeah.
5 to 100, right? We've tended to focus historically on infrastructure and commercial. So infrastructure, commercial projects of 100 million and up is where we've tended to focus.
Interesting. Well, it's been a fascinating conversation, and I know I'm going to have another conversation with a colleague of yours to go kind of under the hood, as it were. But for the moment, René, thanks ever so much for your time. It's been fascinating, and I look forward to hearing more about how this progresses. But for today, thank you so much. It's been fascinating.
Thanks so much, Andrew. Thanks for inviting me. Great to be here.